हेलो अस्सलाम वालेकुम। मेरा नाम वस्मी आब्दी है। आज का जो मौजू है एआई, इज़ इट अ ब्लेसिंग और अ कर्स। यकीनन काबिल फ़िक्र है। अल्लामा इक़बाल का एक शेर अर्ज़ है कि अमल से ज़िंदगी बनती है, जन्नत भी जहन्नम भी। ये खाकी अपनी फितरत से न नूरी है न नारी है। या इसको थोड़ा सा बदल दूँ तो मैं कहूँगा कि ये एआई अपनी फितरत से न नूरी है न नारी है। कहने का मकसद है कि एआई इज़ अ टूल, इज़ अ टेक्नोलॉजी, and if it is used for good, then it is definitely a blessing. And if it is used for bad, for evil purposes, for malicious purposes, then it can be a curse. So I will just take a few minutes to talk about some of the basic concepts and technologies behind AI. So to begin with, what is AI? So AI refers to a machine which can perform tasks which normally require human intelligence, just as a loose kind of definition. So think about a self-checkout counter in a supermarket. So it is replacing a human cashier. So is it AI? Yes, it is in a sense. But these days, AI usually refers to systems that are built using artificial neural networks, uh, or ANNs, sometimes neural nets for short. So this is artificial neural network. So let's talk about that for a bit. So ANNs are a breakthrough in computer science which happened over the last 10 years or so. ANNs are a big deal because with it you can build a machine which learns and gets better with time. So ANN is a software design which was actually inspired, interestingly, it was inspired by the design of the human brain. So a human brain is built of special cells called neurons. A neuron has synapses through which it connects to other neurons. There are 100 billion, with a B, 100 billion neurons and about 100 trillion, with a T, connections in the human brain. So ANNs are very simplified form of that. So artificial neural network also has things that are similar to neurons. They are called nodes. So there are many layers of nodes, and the nodes in layer 1 connect to nodes in layer 2, which connects to node in layer 3, and so on. So that is roughly the architecture of the software. The interesting thing is that the interesting property that the surprising property that these artificial neural networks have is that they can learn from data. They can get better over time. So how? They learn from data by solving an optimization problem. So basically, it calculates the gradient of a loss function to minimize the error between the predicted value and the actual value. So to make this clear, let's take a specific example. So you know this website called Zillow. So they predict the price of a house, the sale price of a house. How do they do that? They use a neural network. Among other techniques, but one of the techniques is they use a neural network. So supposing I'm an engineer working at Zillow and I'm trying to develop this model whose job it is to predict the price of a house. So I will make this neural network model. Initially, it will be simple, it will be untrained, so it will not be very accurate, but I have to start from there and then I will start to train it. How do I train it? I feed it data. What is the data that defines the price of a house? So you can think of the square foot, the number of bedrooms, maybe the distance to a school, and so on. So you can come up with 10, maybe 20 pieces of data which are relevant for this problem. And so we feed this data and ask it to predict the price of that house. And because the model is untrained, it'll just make a guess, which will probably be very wrong. So it might say 100K, just a guess. But the actual sale price is 500K. So what's the error? 500 minus 100, 400. It's a big error. So what happens is this 400 error is fed back into the machine, right? And based on that, the software will adjust the weights in the nodes, which determine the connection between the nodes. So something changes in the software because of this feedback of the error. So the next time the training continues, so I now give it data about another house, and it makes a prediction, and then again calculate the error, the actual price versus the predicted price, feed it back. Again, the machine adjusts the weights. The interesting thing is, and this was proved mathematically, is that by repeating this training process multiple times, the output gets better, the machine gets better at prediction, and the error reduces, it converges to closer and closer to zero. So it becomes more accurate. The accuracy that people try to achieve is like 99%, more than 99%, right? And that is achievable. So how much data do you need to train it? So it depends on the problem. So for the house, maybe it is, you have to send data for 50,000 houses, or maybe it's more, it's 500,000, a million, something of a very large amount of data to make the machine accurate. So once it is trained, then the model will be accurate and it's ready to deploy in the world. So that is roughly a very simple example to give you a sense of what, how these ANNs, these artificial neural networks are trained. So basically, the concept is that the machine learning, I hope you can see this, is a combination of the artificial neural network, that software model, plus lots of data, plus to compute all these mathematical functions over so much data, it requires a lot of computational power through these special chips called GPUs. So GPUs are in great demand by almost anyone who's training and developing these neural networks, like Google and Meta and Amazon, Apple, so on. So for those of you who follow